Hello and welcome to another section in further mathematics. In this section we'll be talking about the parabola. But before that, let us look at the previous lesson. Okay, welcome back. Now let's go to what we have right in front of us today, and what we have here is parabola. Now what is a parabola? A parabola is a locus of a point. Remember when we did that of a circle, we said a circle is a locus of a point equidistant from a fixed point. That is the distance from here is here, this direction, this direction, this direction, and this direction. So we said when you talk about a circle, equal distance means equidistance. So in the case of a circle, the distance from each point, from the center to each point, is equal, so we say it's equidistant. But in the case of a parabola, the point is equidistant from a given point called the focus, and from a given line called the directrix. Now this shape is called the shape of a parabola. This shape, sometimes you have the shape of the parabola facing upward, like that of a graph. You can still have it facing downward. You have it facing the left direction. You can still have it facing the right direction. These are all the shapes of a parabola. Now let's go into understanding some instructions about a parabola. Now number one, we say the length of directrix from V. That is the length of this. This is the directrix of a parabola, and this point is called the V. That happens to be the base of the parabola. Is equal to the length of the focus from V. Now, where is the focus of this parabola? You can discover that it is here. So the distance from here to here is the same as from here to here. This is the focus of the parabola. So they are trying to tell us that if from the directrix to this point V, that happens to be the midpoint, is 5 cm, the distance from this point to being the midpoint to here being the focus is also 5 cm. You cannot have a parabola with the directrix having a longer length than that of the focus from the midpoint. So the line AB, a distance AFO from the y-axis, is called the directrix. Now this is the line AB. Here, this is the line, and from the y-axis is called the directrix. Now this is the directrix that we're talking about with the name under it. The line AF is called the axis of symmetry. Now where is A? These are A point, these are F point. Now from here to this point is called our axis of symmetry. Now the line RQ, which is perpendicular to AF. Now remember, this is our point A and this is our point F. Now there is a saying that there is a line RQ. Now where is our RQ from here? They say it is perpendicular. This is a perpendicular line. Like this is a perpendicular line, and this is a perpendicular line. If this is this stage and this is a perpendicular line. Perpendicular line is any line that makes 90 degrees with a particular line. So if this is a line, a perpendicular line is a straight line that comes to touch it. Now they say the line ever is called, and the RQ line is called the latus rectum. So being perpendicular to it, it is called the latus rectum. V is called the vertex and F is called the focus. So this point is the vertex of the parabola, and it serves as a base of the shape. So if this is a shape, the vertex is here. Never mind my parabola. This is the shape of a parabola. Now the base of it that serves as either the minimum value if it is facing upward, or the maximum value if it's facing downward, is called the vertex of it. Why the distance between here and here at midpoint is called the focus of the parabola. Now if the vertex of a parabola is translated to a point x1 x2, the equation of the parabola becomes this. Now this is a stated equation of a parabola, and the above equation is called the standard or conical form. We are using this to solve in some of the questions we'll be encountering in front of this lesson. We said it is being called the standard form or the conical form of a parabola. So if you've been asked to state the standard form or the conical form of the equation of a parabola, this is the equation. I would like you to note this down, copy it down, because we'll be using it to solving some questions in our subsequent slide. And this equation can as well be written as y square equals y square being equals 4ax. So this equation can be written as y square equals 4ax. That is if the value of y and x equals 0. So we stated earlier, this is a equation of a parabola. Y minus y1 all square equals to 4a in bracket x minus x1 all square. Now at point 0 0, which serves as the origin, then at this point you know that x, this is x and these are y. Let's substitute into this equation. You now have y equal minus 0. Remember y is 0 all square equals 4a in bracket x minus 0 all squared. So y minus 0 is y. So you now have y all squared equals 4a. X minus 0 is x. Then there's a square here, square. This is square. So if you take it down now, then you now have that at this point the equation of a parabola goes in this format, that if x and y sounds to be at this point. But in nutshell, since the value of x is assumed to diminish as the parabola progresses, so we now have the value of this is y square equals to 4as, and this is the equation of our parabola. Now let's solve one equation. Find the focus and directrix of the parabola. Question 1. Question number 1. Find the focus and the directrix of the parabola. Y square equals 16x. Now this is what was given to us. I would definitely like us to convert it into a normal equation. Then we now solve it in getting our values of x. But don't always forget that if the value of our focus for x is 0, then the directrix will be the minus sign of it. The same thing is applicable to the y part of it. So let's go by comparing equation. Let's compare. You know, they said it's y equals 16x. Let's compare it with the stated equation here. Y square equals 4ax. We are about comparing the two. Let's say that x goes with x, then y square goes with yx. We have 16 equals to 4a. So 4a is equal to 16. Now a is equals 16 over 4. That is dividing both sides by 4. And 16 into 4 is 4. So the value of our focus is equal to 4. And remember, if this is 4, then the directrix will be equals minus 4. So with that, the focus is equal to, you put it this way, 4 for x, 0 for y, and the directrix is equals minus 4. I think this is our first equation that we are supposed to handle. Now let's go into solving another equation on parabola. Now, equation number 2. Let's try number 2. We move from the known to the unknown. Now, number 2 question says, write down the equation of the parabola. Write down the equation of the parabola y squared minus 4y minus 12x plus 40 equals 0. Now with this, in its conical form, we're expected to write it down in its conical form. So hence, find I, its vertex, II, its focus, and III, the directrix. Now, in finding this, let's start from the first one. They say we should write it in its conical form. Now, in presenting it in its conical form, you state it like that. You use the method of completing the square. Then we bring down our equation, that is I. Let's solve I. Have y squared minus 4y minus 12x plus 40 equals 0. Now let's apply method of completing the square. We have y squared minus 4y. The half of 4 is 2. Squared is 4. So plus 4. That is for y. Then we still have minus 12 because no, this thing is possible. Plus 40 then equals 0 plus 4, because whatever thing you add to the left hand side, you also add it to the right hand side of this equation. Now take all the constant term, including the x term, to this other side, since you want to present it. But if you have y squared minus 4y plus 4 is the same thing as y minus 2 square. Now we have to state the obvious, that this is completing the square, so that each time you want to deal with this, remember that it's completing the square. Completing the square. Now this is complete. So we have this to be equals, if this goes to this side, it becomes 12x minus 40, yes, plus 4. So this becomes y minus 2 all squared is equal 12x minus 36. So in writing it in the form, we now have y minus 2 all squared is equals, what's common between them here? You have 12 in bracket x minus 3. So it's now 12x minus 36 minus 3. This is the conical form of it. So with this, we're done with the first part of it. So in the second form, we stated clearly that in getting the vertices, but since from the equation, since 12 is equal to 4a, just like this 12, this is the value of our 4a, then our a is equals 12 divided by 4, which is equals 3. Now let's look for the vertices. The vertex I, vertex, we've gotten a, is now equals x, y, which is equals, what's the value of our x, or this, okay, which is that of a, we've got 3 and 2. So that's it for the vertex. Now the focus of this, that is II, focus, we now have equals x1 plus a, comma, y, which is equal to 3 plus 3, comma, 2. So the focus is now 6 and 2. Then I, which happens to be the third part of it, is the directrix. We look for the directrix. The directrix x is equals 3 minus 3, which is equals to 0. So therefore x is equals 0. So I know you'll be smiling at this point in time, but in order for you to keep the memory of what you just learned alive, I would like you to attempt the test that will be coming up on your screen very soon. But always do well to use the lesson notes on the platform for a better information on the topic we discussed. Thank you, and see you in our next class.